Yeah, there we go. All right. I'm gonna turn this on. This is like a, if you think about a piano or a guitar, maybe the chord is 3 notes together. So that's what we're doing here, except we're doing it 3 times in a row. So, but here we go. That's awesome. It's 12 volts. Pretty smooth. So there's been somebody like, saying that I should get a contactless dynamo for my aluminum disc. And so I got 4 of them coming. But it's still, I mean, it might be, over Unity might be a thing because over Unity isn't free. It's not. As long as if you have a power, it doesn't matter where the power in the play is. If you have a battery or a capacitor or anything like that in your build, then it's not free. Free, and by definition, is without cost. So if you look at what a cost is, you'll see that everything has a cost, even though it's not. And I get what you mean by it's over Unity. Absolutely, it's basically for free. You're just putting this thing on there and you're getting energy for it. But one, those things aren't cheap. Definitely not free. And so I was thinking I'd hook them up to the shaft of whatever I'm hooking it up to. Yeah, that'd be sweet. Anyway, they're on the way, so we're going to find out what they're going to be all about when they get here. And I got the Nova. The Nova. That bright star in the sky. And I don't know. I'm gonna hook it up. We're gonna see what it can do. I mean, the one that I got, I think, is 1200 lumens or something like that. So this will go on here like this. Maybe we put this on there first, just so we can get it, so it'll spin. We need it to spin with this. It needs to spin, which is good because it's easier that way. It's freaking a lot easier than getting something with a bearing in it not to spin. All right, and I just got the bearing in there to keep it centered. As long as it's in the middle, it should be all right, whatever we do. All right, so we got 3, right? Doop, doop, doop. And then we're going to turn off 1, 2, 3, and then dun dun dun. Uh-oh. Hook that up. Now, the other thing is I have three DC buck converter transformers, which will go up to 345 DC volts with a 10 volt input, as far as I know. All right. Now I got to be able to deal with this pretty quickly because it's going to get going. Wow, that's got a lot of inertia to it. There we go. All right. Get ready. On your mark. Get set. Go. Now with the voltage increased, both lights are on. So cool. I think that 16 gauge is a little bit much though. We're running it consistently at 24. I could swap it out, but I need a better coil. This is a 1 millimeter and 20 gauge and 32 gauge. This is a tri-filer coil. That would be great if I could get this to work. I mean, yeah. Now, I want to show you the sign of the oscilloscope for Big Red over here. That's weird. All right, I'm gonna unhook the camera from the tripod. Hey, what's up, everybody? I'm gonna show you the oscilloscope reading real quick. All right, so it's about an 80 volt spike. Hello, hello, what's up? All right, so There's the scope reading, and I'm pretty sure if you count them, we got 9 spikes on the screen at any given time. And that's because we can get this reading because this big red coil right here is a tri-fiber coil. It's 20 gauge, 22 gauge, and 32 gauge. So we got 32 gauge trigger, 20 gauge drive, and then we got this 22 gauge strand that is generating about 30 volts of DC just from being in the coil when it's on. That's awesome. But watch here when I turn it off. Let me see if I can't level this. And goes down to what we get from the magnets off a 22 gauge coil is about 5 volts at this speed. So you get both. You get the electricity from the magnets, and you get the electricity from the electrified wires working together in the coil. You get a lot more from the EMF, though. You get way much more. Way much more. Way more. You get virtually what you put in coming out, pretty much. So right now, 25 volts are going in. Now let me turn it back on. So, and as that increases, it'll get up to 25. There it goes. It'll get up to like 28, 29. It's a 9-magnet rotor. So I think the electricity generated from the magnets is way more than having like 3. See, I turned down a second coil. Turned down this big white one right here. All right, there we go. That's what I'm talking about. No, then it drops. Why did it drop? Why did it do that? Can anybody explain to me why that happens? It's all the way up to like 30, and then it goes down to 23. Must be the bridge rectifier is screwed up. Something like that. That could be. Could have something to do with the coil's capacitance. All right, so 75 volts plus, 75 plus spikes. And that's 50 volts above what we're putting in it. So I don't know. It's not that great in my opinion, but it's not bad. Yeah, probably. I was thinking at least that much. Uh, Especially from the AC to the DC. But I haven't measured the AC yet. Should probably give that a shot. Yep, that's right. It's about 100 and, oh, about 89 volts, the AC. Yeah, yeah, that's pretty accurate. It's about more like 7 volts. And that's just on the spike, though, not on the. Wow, that's pretty cool. See, it's awesome how it changed just a little bit there. I'm changing it from AC to DC. There's the DC. At about, oh wow, it dropped 20 volts. Holy smoke, it's a big drop. All right, this is AC, 106 volts, 105, between 105 and 110. Oh, I'm not sure exactly what it's for. I bought it as a part, not from anything. I didn't scrap it. So I could check and see if it belongs to a washing machine, though. That's awesome. Yeah, we're generating about 24, 25 volts. We're putting in 24, 25 volts. So it's virtually just passing through uh, one-to-one transformer right here. That's what it ends up being. This coil is like a one-to-one transformer. Heck yeah, man. These things are, well, I mean, I wouldn't say they're too expensive. They're not cheap because they're above $5, but they're not that bad. So I hope you get one too. All right, so I'm going to drop it back down to 12 volts. That's easy. Now, these parallel coils that I'm working with each have their own power supply. And their own circuit. So there's one. That's the one we've been working with on the meter here. And look, see that coil, that 22 gauge strand is still generating like 5 volts from the speed off the rotor. But when, man, if the dynamos work like I think they're going to work, I should be able to funnel that energy back into the system, since it's not really, the system doesn't recognize it as part of the system. So that should be interesting to see. Because as soon as it's recognized, then it becomes either a load or a power source or something. And if you already have a power source, having a second power source is probably going to muck stuff up. So I don't know. We'll see. I mean, you could probably do it a bunch of ways. But this is an interesting look at things. Contactless dynamo for the aluminum disc that I have. It should be really interesting to see what happens. Oh, they're all MPNs, actually. All right, so I'm going to put this back in its little holster because I'm going to go grab some. It's my latest project. All right. Good deal. I'll be right back. Yeah, man, this thing, if it works the way it should work, should work. I'm not even really worried about it not working. But all right, this is it right here. It's virtually just a little top. It's a spinning top. It's a counter rotator. So you spin the top, right? And the magnets should engage with the coil, which is right here. And then there should be some circuitry in there. Should be glued to it, but right there. It'll be glued to the base, and then it'll have its transistor in there. It'll be high enough so that everything will fit in there without being knocked by the rotor. Well, after lots of tweaking, I think it's going to work out just fine. I'm going to cut off the top of the shaft, and it should just be a souped up spinning top. Let's get some water real quick. Now let me think here. We could try that. Well, let me actually hook this one up because it's already ready to go. All right, my family's going to be coming home maybe soon. They said they were going to the store. All right, so that's the state. Let me get refocus the camera here. All right, that's the stator for the motor. And this is the rotor that I use for it. Oh, no. Okay. That's unfortunate. Oh, yeah, that's right. Never mind about the unfortunateness. I just need to get my wrench, and I'll be right back. Need to set this up real quick. Forgot about that part. Yeah, I really can't wait to get those power sources in here. That's what it is. It's a power source. Now let me check real quick. It might be a little. Oh, yeah, it's a little too low. Like the hair too low. Now I got this Litz wire coil, but it's in my storage space. And I wanna use that to run some stuff. Now, the problem with this one is that the weight is a little off on the bottom, on the stator. It's like it's not. But it moves like the Dickens, just like the top does. And if it was a little bit, maybe a little lighter and a little bit more balanced, could get going really fast. Is there a purpose for it? Like, is it going to go in a car? I don't know. Not like that. But some variation of this might end up in a car. Yeah. Because its principle is that it continues to gain speed if it's built right. It doesn't ever slow down, really. And it continues to gain momentum to its potential and beyond, I would imagine. Especially if you're just using 20 gauge coils on a little plate. You know, in a typical situation, you only have to the coil's potential. Doesn't matter what you put into it. I'm talking like max RPMs. I'm talking like RPMs. Because you get to the point where you're putting in voltage and you actually start to slow down because you've reached the potential. So there is a sweet spot when it comes to voltage, I would assume. And current. I'm talking, when I say voltage, I mean wattage. That's what I mean. This debate over voltage and current and what's more important, they're both important. It's wattage. It takes wattage for any of this stuff to work. So they're both important. Now, there's other stuff out there I'm learning about right now that, you know, it's different than all this. It's different than AC and DC electricity. Now, I don't know the pyramids in ancient Egypt. You know, they had the big pyramid, and then there were smaller pyramids surrounding it. I'm not exactly sure about any of it. Really, it's been a while since I looked into it. But you know, it's been said that those were, you know, wireless transmitters, resonators of power. So the tip was made of gold and yada yada yada. Very, very possible, very cool. And yeah, man, I think it's great. But the little pyramids is more what I'm mad about. They resonate too, you know. They're built to do something. And I just, if there was, you know, a way to pacify anger and rage and emotions like that, just to make them go away by a certain frequency, I bet you people would do it. What I mean is a resonance, a sound. It's a sound. Resonation, it's a vibration that pacifies those emotions. Simple. It's really simple, actually. When you think about it, it's just a vibration at a certain frequency that calms people down. It's novelty, man. Back then, though, it was used to probably pacify a populace, doing what they were told. But I don't know. I have no idea. I mean, I'm still trapped in archaic thought where, back then things were worse. Now I'm starting to hear that back then things were way better than they are now. So I don't understand, what. And I think the more we find out, like factually, the better off we'll be. But it's like you find a head, like a stone head in the sand, right? And you uncover it, and it ends up being like a 30-foot statue, you know? So, yeah, man, lots of somethings have happened over and over and over again. I don't know. I find it fascinating, especially with it being so close to it's Thanksgiving. Happy Thanksgiving, belated Thanksgiving, everybody. So yeah, I mean, if it's true that our cycle, if it's a 27,000 year cycle, and we pass through the asteroid belt twice in that cycle, then we're due for another round pretty soon. We are due for another spin. If the last contact happened, 12,000, 13,000 years ago, then the next one is coming around the corner because that's half of 26,000. But I think, somebody like all this space. Oh, here we go. Family. What's up, son? Hey, Paige, daughter. Hi, Jenny. I get it. All right. Oh, yeah, that's what I was going to do. And it was all set up, too. My bad. Okay, we're going to do that. We're going to do this. All right, and so this is the cord for 12 volts. It's not, you can't really hear it too much, but it's pretty solid. It's nice and smooth. All right, so I'm going to take this off of here. Can I throw this box out? Like, will you know how to do these if I open the box? You can get rid of the box, yeah. Yeah. So I was thinking about making another 3 coils for that, but having them be off when the other 3 are on. So on, you get what I'm saying? Off when they're on, kind of thing. Like these 3 are all hitting on positions. So if I put it like right next to the coil, that's not what I want to do because the coils interfere with the other coils. Oh, my cat wants to get out. I didn't know he was in there. Okay, so we will remove this. Like that. Oh, that might be the problem. Oh no, that's all right. Okay. Thought I broke the 32 gauge end like in the middle of the coil. I was like, oh my god, it's not good. But we're good. So this monstrosity right here is actually almost an SG. Actually, I gotta move. It's a duplicate. It's cool. I got one here, and then I got one over there. I need to move that one over there, over here, along with this battery. What's up? Hey, hey. All right, so we're gonna use this battery. All right. Base. We're gonna get some.
There's no way. There. Bring some of those. Yeah.
I might need to use a different battery. Just do that right away.
Oops. All right, well, I am wearing green now.
There we go. That's not cool. Did you guys go out to eat too, or what? Yeah. Right. It's got good flywheel capabilities. This rotor that's spinning. So, did you guys eat? Are we going to eat or what?
I'm gonna make a ham and mashed potatoes.
Okay. Sounds great. Go. Okay. Yeah, my birthday's coming up, so that's gonna be awesome. Gonna be 44 years old. Whew, that's nuts. It's a bad coil, I guess. Oh. Maybe if I turn it upside down? Well, it looked like it was on, like perma on already. What can I do? What can I do?
Oh, the last one, no, that was good. Oh, the last one. Let's run. Let's run. He's coming. He's coming.
All right.
No. Oh my God.
I'm going to connect the 18 gauge and the 20 gauge strand. Yeah, that's got to go. There we go. Nice coat.
Well, I wouldn't be too much. But I'm going to be making it. Okay. I'll be right back.
Okay.
I'm making ham and mashed potatoes.
Okay. Yeah, sounds good.
I would probably start at like 2.
Okay.
And it's one of those little like half zucchini, it's got like little slices.
Huh.
I didn't get that good. Oh no! This.
That's cool. So,
This is already cooked, right? Just kind of keep it up.
right. Most of them are.
All right. Alright, I'll do that.
Okay.
Did his pictures come in the mail?
I don't know. I haven't been to the mailbox in a while. I'm gonna go down there. I should go down there later.
He must have got that from me.
Alright, it comes in a white envelope. And it's got a piece of cardboard in there so they can't get bent, but, alright, I'll do that.
All right.
Okay, I don't know how long it takes for pages to get here. Then I think I only ordered this like a week or two ago. I don't know.
I think how loud it is. No.
I like how it's moving on its own, but I don't like how it's let's see here. Let's try it now.
I'm not to make any mistakes. I already had it. How did I not figure it out?
I think that'll work now. Let's see.
Oh. I can't hear crap. Yeah, look at I'm getting that. So. That was fun, wasn't it?
All right. Nothing.
No, I'm not going to play. I'll be waiting for you to get in.
I'm really starting to think that my coil is
Probably not.
sketchy at best. That one at least.
Why did you ask me? Why did you
No.
ask? I'm calling you. 4 times done. Yeah, I've already understand. Because you were texting. Well, I texted him and then we started texting. Who's calling me? What is good? I like the call because Jackson's calling me.
Yeah, nothing. All right. Well, that sucked. It's all right though. That's what happens when when you're doing something that sucks. You can't do it forever, or you just get discouraged. So you move on to doing something else. Yeah, there's a whole lot of stuff that just doesn't matter to me. One, this rotor is balanced as hell, but it's going to shake a little bit once it gets going pretty fast. I'm not worried about it. Not even that much. As long as it doesn't throw a magnet, I'm good. And the way it's built, it shouldn't throw a magnet. Unless it starts lifting up this pole, which there's going to be a lot of friction. I've designed it that way. I don't want this thing taken off. Beep, 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 boop, boom. Now, I got an idea. We'll use this coil instead of that monstrosity. And just imagine if we had the contactless dynamo and the aluminum disc going that fast. Freaking A, man. We'll see. But we'll see what happens. We'll definitely get a good idea. No. Man, what is the problem, I wonder? I'm going to try swapping the trigger strands. Nuts. Well, we can hook up the pot and use this one over here. That's probably going to be what I do. So that power is off on that motor right now. Well, this is moving right along swimmingly. I just hope this is all still connected right. I checked it, but that really doesn't mean much. Looks like all I gotta do is plug in the power. Okay. Mm. No, no, it was an idea, but something isn't right. Something usually isn't right. What is this for? Huh? So I'm just thinking about if I want to try and do this again, where I want to do it at. All right, so start from scratch. Because this is probably just all hooked up wrong, honestly. That's not true, but I just want it to be an easy fix here.
I almost ran out of flour. I almost ran out of flour. I'm over that.
So the power will go directly to the collector.
What did that happen?
All right, and then the light will go collector to emitter. Then emitter will go to the coil.
Look around.
I'll be right back.
So good.
All right. Okay. So we were here at the coil, going out the coil to the negative of the power supply, and then the trigger will do the same. I can just find, there it is. Need a little bit bigger clip than the little battery. Need a bigger battery. The only problem with hooking it up directly on the transistor is you don't have any room to run the pot. Maybe. Let's try it. No. Yeah, we can do this. So when we're not using a breadboard, we don't need that. It's all right. Middle goes to the base. Ooh, that would be awesome. There it is. All right. So you see that? When I turn the resistance up, the coil like moved out. That's weird. Okay. Maybe we take the pot off for now? Or we take the trigger coil off? I'm not sure.
Oh yeah, I'm sorry. Oh, and I do get here, I know what to add. Oh, that's for you.
You can kind of hear it. It's weird though. I don't know about this one. It's probably the transistor. At this point, that's what I would assume. So I'm going to swap that once. Fair enough.
I wasn't getting close to that. No.
All right. So much noise going on here right now. I can't like focus. But we're going to do our best. I'm going to try this one with its own transistor. Should we try one of these? Or should we try this one? They both are kind of cheap.
The lower one. On Bale Dingle.
Might have to do two, but we're going to try the really cheap ones first.
Let's go.
Okay. Base connection. Collector.
Bro, I was like, I was so tense when I was my back. So good. If not, try to go for something powerful. I'm gonna try to go for cloud because for me it's the most tricky. Yeah. Well, it's gonna be too for more harder.
Yeah, it's so hard for me to think right now. It's unbelievable.
I want bananas. Yeah, I had more people in the beginning that were kind of yeah, especially that one. Here, right here. But I'm gonna be right back, so I'm gonna be okay.
So that's my power plug. And then the light goes collector to emitter. And then the pot goes here on the base. Oh, that sucks. So heavy. So heavy. Come on, man. Should I get some Velcro? That'll work, I guess. Hmm.
I'll take off the back.
Hmm. I mean, the pot is having an effect, but it's not working. So I got the base hooked up. I got the emitter hooked up. All right. So, huh.
I want to get enough diamonds. Enough diamonds. Everybody is seeing always upgrade. So I'm just gonna wait for the Guardian sponsor and get a lot of diamonds out. I have this one.
Overpowered.
I got 4 diamonds.
Yeah. All right.
Dang it! What's the extra iron on the other? So what's the next?
Yeah, well, I mean, transistor after transistor. Hmm. Let's get those separated. See if that helps. No, that's. Mm. Man. Well, I don't know. I have no idea right now. There's too much noise going on in here for me to even think. But that's all right. Some of this stuff I don't need to think because the thinking's already done. So that circuit right there, the one right in front, this one is operating this coil. Go figure. Here, let me try this. Wow. So, huh. Yeah, I got a lot of transistors coming, so we'll be able to mess around a little bit in the near future. And these I can't even read. I can't read these. But I'm pretty sure that's a transistor issue. I like it when everything works, though. It's really neat. Yeah, my bad. Totally my bad. Um, but there we go. Camera angle is fixed on what I'm doing. I just had it over there because I wanted to let you see me make it work, and it wasn't working. So I apologize for that segment. We'll get it going though. Hopefully, I was just hoping to get it going live. That happens rarely. See, this was already pre-built. I built it before we went on. So we got our 9-magnet rotor, 40 degrees of separation, but at 8 inches, it's about 1.5 inches apart, 40 degrees. And like up here at 4 inches, you couldn't do 9 magnets. It just not like this. No way. But like you could do really little ones, you do tiny ones. But when it's small, you don't want a bunch of magnets. You want fewer magnets. But since you've got 1.5 inches between each magnet on this one, 9 is okay because 1.5 inches is a lot of space. But I call this one Melody because of the chord. You got 1, 2, 3 on 120 degrees, and they hit at the same time. So that's the chord, ding, ding, ding. Right? Like on a piano or a guitar, or it's the melody of the 3. So we're going to scope that out again. Yeah, I apologize. I got really into doing that and it didn't end up working. So, shame on me. You can kind of hear all 3 sounds hit at the same time, which this is what it's designed to do. Now, there is one thing that I want to show you. And what I got to do is I got to remove 6 magnets from here. And we'll get the true melody going. Because right now it hits 3 melodies, one right after the other. And so it's real jumbled together because there's 9 magnets instead of 3. But if I remove the 6 and have the 9 magnet or the 3 magnets at 120, then you'll kind of get what it's supposed to sound like. Yeah, that's smooth. This is a trifilar coil, so I have the extra strand hooked up to the multimeter. That's pretty sweet because it shows the spike of the collapse of the coil after every magnet. So 9 magnets, 9 spikes. That's only if your transistor can keep up with that. Because not only is it starting to move pretty quickly, if I could find my, man, there it is. My tack meter. Okay, so we got 1,085. 1,085 times 9. That's how many spikes we're getting per minute. Now, let's do the math. 18,000 or 8,000 times 2 will be 16,000. So you're getting, but you gotta, your rotor's got to be going 8,000 RPMs, okay? At 2 magnets, it's doable, but at 8,000, you'll be getting nearly twice as much as you are with 9 at 1. Amazing. Twice as many spikes at 8,000 RPMs, but I don't think, no. you gotta show me the scat on that. The math, I just did the math in my head, and yeah, the math works out if you're going 8,000. But if this is going 8,000, that's 72,000, right? Or 7,200. 72,000. No, 7,200. And then that 2, oh man, I'm lost now. 8,000 times 2 is 16,000. But 8,000 times 9 is 72,000, right? Okay. Can you ever get a 9 magnet rotor to go the same speed as a 2 magnet rotor? I have no idea. But I know if you keep all the constants the same in both tests, I'm willing to wager the answer to that is no. So the weight, both of your rotors are balanced. They weigh the same. Because of the time, the same amount they run for the same amount of time. Okay, if it's not a smart goal, it should be thrown out the window automatically. It's got to be a timed thing. You know, an acceleration phase, if the motor's good, shouldn't be more than a minute. And so that would be your time limit. Your time would be a minute. Whatever happens within that minute, you know, just an example, is fair game. Anything beyond that minute, it might end up being really, really cool, but it doesn't factor into your experiment. So, and yeah, I mean, some of these things, if you leave them running, will demonstrate miraculous things like ion fields, the beginning of a bubble, because you got to create it and then you got to expand it. So, at least that's the way I feel that it would work. You get that purple ion sphere all the way around your thing. If you build it up the right way, it should form literally a bubble. But yeah, man, the gravity flyer things, really cool, man. Especially when I saw the purple ionization field from the spin, not the lightning strikes, but the actual like field. Man, that was awesome. That's what's supposed to happen. But it's supposed to get way more than that. But that is, yeah, I got excited when I saw that. I was like, yeah, that's cool. All right. All right, I gotta get, well, I don't have to get, but I'm gonna get my flange. Wow, these are in short supply right now.
Roll this guy has that's something about maybe.
So if you can't see me again, I apologize. I will fix that.
I know it does.
And if I didn't need both my hands, I wouldn't need a cameraman. Mm. All right, so the idea with the dynamos is to attach it to the shaft and have this disc spin freely.
Make sure that that's it. Or give Jack too much iron.
Oh,
I'm sorry, but how? Unless you're happy. But how cool. For people who play.
wow. The magnetic field is so like strong against these perms.
I can buy one. Alright, I'm gonna be on the other side now. I'm gonna go put my
But yeah, we get that axial flux going, and this aluminum disc will be spinning with it. We hook the dynamo up right here. Maybe even two of them. You know, if we can get it to clip right, you put two of them on there. All right. Jeez, my kids are having fun. All right. All right, let's see if this one will work. We should switch these back. I don't know what's going on, man. I don't know why it's not working. Nah. So I'll have to get down. I might move one of these SGs over here, and then it'll run better that way. Probably blow a lot less, a fewer amount of transistors as well. All right, I'm gonna do this real quick, and I will be right back. All right, we're gonna try 3 and 6 on this spread right here. So we'll try 3 first. That's all 3 of them at the same time. That's so cool. I love the sound. Pretty solid. I like it. No, that's not working. There it goes. So we got to do that again, actually. And then we'll do 6 magnets. Pretty much done 9 up the wazoo. All right, so we'll do this one more time. There it goes. Now, 3, the 9 went about 1,100 RPMs. The only thing we've changed now is how many magnets are in the rotor. It's the same rotor, same weight. It just has three magnets in it now. Yep, 1233. So that's a win for 3 magnets. It's awesome. But I don't know how long that wasn't working for, so I haven't been paying attention. But I can't wait for those rim dynamos to get here. Hook them up on this.
I'm good, I got it.
I got an even wackier idea. 3 coils. And we're gonna go even less now. We're gonna go 2 magnets now. It'll be a different rotor. A stronger magnet. All right, man, this is gonna be awesome. 12 volts. That's cool. I don't think it'll be going very fast. Maybe I'll be wrong about that. So that's 700 RPMs. I think that's sweet how it's hitting though, man. Just in my head, that's like powerful. What it's doing, it's like nothing is hitting at the same time on either side at any given point. Really strong. Now we'll put 6 on there. We could put 12, but I know what's going to happen if we do that. Now this should hit the cord twice in rotation. There's 1, 2. All right, let's give it a whack here. Boom. Boom. Ooh, it almost started itself. Not. In order for that to happen, your coil has to be able to push the magnet past at least one of these other coils enough for it to turn on. So that's 2 coils. Oh, listen to that fan. Woo! Nice. I think that's nice, man. That's powerful. It's a lot lighter than the other one. Still only about 900, 850 RPMs. Yep, 850. Yeah, it's about going to be its max speed, I think, at 12 volts. Not bad. Not bad. Well, it's not free. The word free by definition is without cost. And I guarantee you, if you just check every single place, there's nothing without cost. Now you can get over unity, you can get more out than what you put in, but that isn't free. You gotta put something in. Even if it's already there, and all you have to do is take it, it's not free. It's the wrong. I've always thought it was like the wrong way to go about expressing what's going on. It's not free. It, even if you just are harnessing the light from the solar, man, it's not free. It's green. It's not free. And it's all right, man. It's gonna end up just rubbing me the wrong way till the end of time, because it's the easiest way to express what's happening. And naturally, the path of least resistance is what's going to be adopted. But that's all it is, the path of least resistance. That's nothing special. I mean, if you don't already know what it is, the path of least resistance, and you're finding it for the first time, then it's pretty cool. Yay, we found it. All right. Then everybody walks it, and it's not a thrill anymore. 10 years, everybody's doing it. You know what? And I mean, seriously, all you got to do to soup up your bifilar motor is to put a third wire in there. In every coil, put a third wire in, and then boom, you've then, depending on how many coils you have, you've multiplied your energy by that much. Additively, though, it's like each wire will have basically a mirror image of the input, plus or minus a couple volts. And that right there, man, that's exponential gain. Each one of these coils has an extension cord attached to it. Where, oh man, dude, but it's not free. It's not free energy. It's exponential gain energy. What's the difference? This has a cost to it and will adhere to the laws of physics and still blow them away at the same time. It's like, yeah, we're following the rules, and yeah, here we go. We got an extension here, an extension here, and an extension here, which can run or charge or light stuff up, you know. And just to prove it, hopefully this will work now that I've jumped into the fire from the frying pan. What do I do? You can't use this one. Well, I can't use the big light, but I can use a little light. If I can find it. Oh man. All right, I'm gonna go grab the LED. I'll be right back. Yeah, 12 volt LED. Gonna hook it to my 22 gauge extension strand and see if we get light and how much light we get. It's just a 12 volt. We'll do DC. Oh, there it is. Let's see if we can even light two of them. How about that? Okay, we're not going to use the bridge rectifier to do this though. All right, there's that. We'll hook up the next one. So 24 volts, I guess. Two 12 volts in series. Well, and that's probably why they're all broken anyway. But the clips, like, don't clip anymore. I'm going to have to settle my kids down in a second here. All right. So we're just going to run the one then at 12 volts. We're lighting both LEDs and the output of the SG is over here. So there's our extension cord, lighting both of those. Output, lighting this light. So that's a solid 12 volt light right there. That's 12 volts into a 12 volt. So what's happening with that strand is that it's being, it's like a transformer, a 1-to-1 transformer from the power cord to the extension cord. And then the interaction between the trigger coil and the power coil are and I'll turn it up to 24. See how much brighter everything is? So it's like a mirror image of what you put in, pretty much. Just an extension cord. But it's contactless. It is not, nothing's touching. It's all using the air, the energy around the wire. It's a transformer, just that coil right there. And because it's only, because it's a 22 gauge strand instead of like a 32 gauge strand, you don't get any really light off of the energy generated from the magnets. You only get it from the EMF, the electromagnetic field, which is, transduced to the 22 gauge wire. Awesome. So I think that's the best part about having a trifilar coil is that strand is a virtual extension because it's going to be the same length. If you wrap it from start to finish, it should be a 1-to-1 ratio. But see, if you don't do start to finish with both strands or all 3 strands, you can do some pretty miraculous stuff.
Okay.
I'm going to experiment with a little bit more of that, doing the different length multi-filar coils. Straight wind, of course. I'm not doing any Litz wire like that. I'll be doing probably trifilar or a 4-filar max. Yeah, so, I was thinking about making this really teeny one. I seen it like on, it was a YouTube presentation about different coils and max RPMs per coil. I've already exceeded that with some of my coils, but the 50 turn 32 gauge 4-filar coil, and I'm thinking you would wind 150 of that into series for the trigger, and then you would use 50 the last strand for the drive. Teeny drive, man. 50 turns on a bobbin like this. On a bobbin like this right here. So nice. Man, those lights, man. All this stuff is pretty sweet.
Look out! Look out! Look there. Guys, the pen is broken. I didn't
So why I keep walking up over here is there's a power supply over here. There's a battery over here that I got a clip to turn it on. But it controls this coil right here. So you can see how the aid of the other coils and the speed of the rotor help with the electricity and every other coil. Especially when it happens when a magnet passes. The faster those magnets pass, the more crisp and stable your electricity is going to be. They're not flashing at all anymore. That's awesome. Neither is the output. Awesome. So I'm not going to do that right now, but I'm going to put all the magnets back in this rotor. Mm. It's funny how I'm trying to do this one over here. This one works every time I turn it on. And that's just the way the cookie crumbles, I guess. And it's like what I was trying to do was run this one, which is exactly the same as the one that one's running. It's exactly the same. I wonder. But, you know, eventually here in the near future, I'm going to have to clean all this up again. Don't mind doing that. I might refurbish the table, make it, get it looking pretty. Like, replace the pegboard. Except I'll turn it upside down this time so the black is facing down. We got a nice brown finish. Be a lot easier to see that way. All right, so we're getting a little bit, really little bit, but they're lighting up definitely from the magnets. Now I have a ton of stuff, but it's over at the storage. Oh. All right, we're going to be having our Thanksgiving dinner here shortly. Everybody had something to do yesterday, so we're doing it today. So that, I don't know, man. I think this stuff is really cool. I think Tri-Filer is the way to go because you have this extension that's based on a 1-to-1 ratio transformer. What you get in is basically what you put out when you add your magnetic induction to your electrification. When you add those two together, you get more than what you put in. Most of the time. Like if you put in 24, you can get 25 to 28 out. Just because you'll get the 24 out from the transformer, and then you'll get whatever you get from the magnets. Automatically, you're getting more out than you put in, but it's like all the math still adds up. If you just have to disclose where you're getting your energy from. So yeah, and it's up to everybody else to decide how awesome it is, you know. Absolutely. It's like, I think it's cool. Mm. So those are on set. Now, let's move this one to here. Hopefully I didn't screw it up. So I don't know if I can do this. Let's see. Those are really close, so I don't know. It's probably going to interfere with one another, but we'll see. Oh, I think that's going to work. So never will there be two active at the same time. That sounds awesome. You can really tell when it's starting to speed up. And there's that disharmony that you're looking for, that like consecutive chirping instead of all at the same time like a melody. Just consecutive. All right, let's check it out. Yeah, it's still speeding up. It's at like 1183 right now. Almost 1200. So, I mean, literally, quite literally, the next thing I'm going to build is this. This is the design right here. You got your plate that is attached to the shaft. You see how it's attached? And you spin the shaft, and then the coil and whatever's on the shaft should go one way, and then you can spin your rotor the other way, or maybe it'll start spinning that way on its own. You got a counter rotator then that'll eventually, if it gets going fast enough, balance out and spin. Keep going faster and faster and just keep spinning. But that's in theory, that's the theory. So, yeah, this thing is going to be awesome. This is copper infused PLA. So it does have a bit of a tug, a small tug to it, magnetic tug when the magnets are passing. But I think that coil will be enough to circumvent any problems that may occur. 1214. That will be an untethered, unbridled top. It'll be a souped up top. And it will spin. Hopefully it'll do what it's supposed to do, which is continue to increase in speed. That's so cool, man. That is great. See, all right, there you go. Look at all that light. Two 12 volts. Dimly lit off of the magnet stuff. Electricity. So neat. All right. Well, thank you very much, ladies and gentlemen. Peace out. Have a wonderful day. And we're going to have our Thanksgiving dinner now. Thank you. Please like, subscribe, hit the notification bell. And let me know, like if about my counter rotator design, what you think about it, because I got ideas. So yeah, just let me know. Peace out.